Good morning, dear students. Let's start chapter 13, atmospheric pressure and winds. In this chapter, we're going to see about the factors affecting the air pressure. Then, we're going to see about the distribution of the pressure belts on the earth. Then, we're going to see about the wind systems of the earth. Now, this chapter is slightly lengthy. So, I think it will take 3 to 4 sessions, but all of you just watch it very carefully, because I am going to explain you in a very simple way all these concepts. And after that, I will also explain you about the jet stream. Now, jet stream is not in your syllabus, but whatever thing is given in the chapter, I will going to explain you. Well, jet stream is very important, we can't neglect it, that's why I will explain you about the jet streams, well, a slight description, so that in class 10th it will help you about the El Nino. Then we are going to see about the periodic winds, and you will study also about the special winds around the earth. In this, we are going to see about the cyclones and the anticyclones. So this is the content of the chapter, and so let's start here with the concept of air pressure. Now all of you know, first of all, about the pressure. So pressure, all of you know, pressure is equal to density into temperature into constant. So if you find here, usually you have studied in the science that pressure usually, that is combined of what thing? The density of the substance and temperature into constant. In constant we can take the gravitational force, and that tells about the pressure. Well, now here is the air pressure, atmospheric pressure. Now air has, all of you know, has got the weight. So it exerts weight on the earth's surface. And this air, it depends upon the temperature. When temperature is very hot, so what happens? The density of the wind, means the air, it becomes very high. But when the temperature becomes very hot, now what happens to the volume of the air? It becomes very compact. So density also becomes very high. Now this is the thing actually you can find. So what happens here? Now what happens here in this atmospheric pressure? Atmospheric pressure is nothing but, in a simple way, let me explain you. The weight exerted by the air on the earth's surface, and we can define it as atmospheric pressure. Now this atmospheric pressure also depends upon two things: the density of the air and the temperature. Now this constant, that is the gravitational force, remains the same. Now these two things, temperature, it gets high and comes down, and that also affects the density. Well, so this is about the air pressure, concept of air pressure. Now all of you know about the air. In the previous chapter I explained you, air is the mixture of gases forms air. And the air which exerts pressure on the earth's surface, that we can call the atmospheric pressure. Now let's see here, next thing, the factors affecting air pressure. Factors affecting the air pressure. The first factor is altitude. So all of you just listen it very carefully. Now altitude means height. Now what happens as we go up? All of you know temperature keeps on decreasing. Now what happens about the air? Now air has weight, all of you know. So most of the air, means you can say that the air is very dense close to the earth's surface, but as we go up at the higher altitude, so the air becomes thinner and thinner, and this is why the layer close to the earth's surface, it has very high atmospheric pressure. So we can say close to the earth's surface or in the lower layer, atmospheric pressure is high, but as we go up at the higher altitude, so air becomes thinner and thinner, and so the atmospheric pressure, it becomes lower and lower. This is why you can find that in the hilly areas the atmospheric pressure is very low, and that's why the mountaineers who usually used to climb the mountains like Everest mountains, and there are so many, Mount K2, Kanchenjunga, and so many hill mountains, high mountains are there. So in that they carries the oxygen cylinder. Why? Because with the atmospheric pressure is low, they at that altitude they need the oxygen. Well, second factor is temperature. Now what happens to the temperature? Let me explain you. Temperature is a very important factor. Now what happens in the summer season? If you watch, the temperature when it becomes very high, means very hot, and you can see the air, wind, very hot wind starts going. So we can say that the air also becomes very hot. So what happens here when the air becomes hot? The intermolecular space in the air, it widens. So what happens? The air expands. So when the air expands, now it exerts less weight on the earth's surface, and so atmospheric pressure becomes low. Atmospheric pressure becomes low. But in the winter season, what happens? When temperature becomes very cold, so the air, it gets compact, and what happens? It exerts more weight, and so we can see, you can observe in the winter season, atmospheric pressure becomes high. So this is how the temperature is a very important factor. In fact, this factor is the most important one. So when the temperature is very hot, atmospheric pressure becomes low. But when the temperature is very cold, atmospheric pressure becomes high. Now the third factor is the rotation of the earth. Now rotation of the earth, all of you know, already I explained you in class in chapter 1 in the previous chapter about the Coriolis effect and centrifugal force. Now what is the Coriolis effect? Just open your book also when you watch the video. So my suggestion is all of you sit with your books, and all of you open the book, and then this explanation will become easier for you, because you need to see the figures and the diagrams given in the book, and the things which are given, the content, it will also help you. So just open it here, the next page in your chapter, that's chapter 13, and there is given the Coriolis force and its effect. So what is the Coriolis force? So you can just look at your book, I am explaining you. Now what happens? All the moving bodies means the wind is a moving body. Then the ocean current also is a moving body. So not only air but water, that is the water in the ocean, it is also a moving body. So what happens? In the northern hemisphere, all the moving bodies, they deflect right hand to their natural path, and in the southern hemisphere, they deflect left hand side to their original path, and this is known as Coriolis effect. So this Coriolis effect also affects the atmospheric pressure. Now what happens here in the Coriolis effect, as all of you know, one example I can give you, example of Bay of Bengal. Now on the head of the Bay of Bengal, what happens? There is a low pressure is formed in the month of October and November, and in the month of March and April. In these two seasons, the low pressure is created over the head of the Bay of Bengal. So let me just show you what is the head of the Bay of Bengal. Now here you can see this is the Bay of Bengal, and this is called head of the Bay of Bengal. And what happened here? There is a low pressure is formed in two seasons. So the first is in the month of March and April, and second in the month of October and November. Now what happens? This low pressure, it attracts all the winds. So whenever the cyclones are formed anywhere in the Bay of Bengal, they are attracted to this low pressure. That's why you can find every time when the cyclone they originate any part of the Bay of Bengal, they always hit Odisha or West Bengal. Why? Because there is a low pressure which attracts. So usually what happens? In fact, you can say, all of you know about the wind. Now there is a difference between the air and the wind, which I already explained you in the previous videos. Now air is the mixture of gases. But what happened? The movement in the air, the horizontal movement in the air is called winds. But how these winds they are caused or how they originate? So what happened when, let me just show you here. Now suppose the same thing, this is the head of the Bay of Bengal. Now this is a low pressure, and suppose here is a high pressure is there. Any cyclone is just originate here. So usually what happens, the wind blows from high pressure to low pressure. Usually the wind blows from high pressure to low pressure. So in any region of the world, when two different pressure regions are formed, high pressure and low pressure, so what happens? The air starts moving to the low pressure, and this is how the winds are originate. So whatever the winds, all the winds, that is local winds or the permanent winds or maybe the special winds, you will find all these winds they originate in the same manner. Means from the high pressure to the low pressure. Well, so I was explaining about the Coriolis force. Coriolis force, I told you. Now here I explained that how this low pressure is very important. Now let us see about the Coriolis force, and with the diagram let me explain you about the Coriolis force. Now usually in the subtropical region there is subtropical high pressure belt is formed. In short form here I am writing subtropical means STHP, that is subtropical high pressure belts. So in the subtropical region you can find there is a high pressure belt. These are the permanent high pressure belt. On equator there is a low atmospheric pressure belt is formed, which we call doldrum. Now what is doldrum? These are the low atmospheric pressure, atmospheric pressure belt. Now what happens, all of you know, the wind blows from high pressure to low pressure. So this is why these winds usually, so they go from, you can find high pressure to low pressure in the both hemispheres. But all of you know the earth, it rotates on its axis, And because of this rotation, in the northern hemisphere, these winds they deflect right hand side. You can find here, this is why these winds which deflect right hand side. Now these winds usually, that's why they are called northeast trades. In the southern hemisphere also, they deflect left hand side. And we call it southeast trades. So, these are the winds, as I told you, I have explained you, let me just just tell you, this is about the Coriolis effect. So, what are the Coriolis effect? All the moving bodies, they deflect right hand side, you can see here, deflecting right hand side. This is only one example of trade winds, that's why we call it northeast trade wind in the northern hemisphere. In the southern hemisphere, they deflect left hand side, that's why we call it southeast trades. So this is the one example that what is the Coriolis force. How all the moving bodies they deflect right hand side in the northern hemisphere and left hand side in the southern hemisphere. This is Coriolis effect. Okay. Now next is because of the rotation of the earth, one more thing occurs and we call it centrifugal force. What is this centrifugal force? In fact, this is the most important one which affects the atmospheric pressure. Coriolis effect doesn't affect directly, but centrifugal force, it is also created because of the rotation of the earth. So, now one thing all of you know, as the earth rotates, and because of the rotation, the earth is slightly flattened at the poles, while on equator it is slightly bulging. Why it is? One example you can take. You take one glass of water and you stir it with the spoon. So what you will find in the center, you will see there the water, it just forms a depression in the center. So the same way as the earth rotates on its axis, because of that on the poles there is a compression movement takes place, and because of that it is slightly flattened. But outside means the sides actually, there is outside movement, outward force that is created, and because of that the sides on the equator are slightly bulging. The same way actually this thing also affects the atmospheric pressure. Now how? On the equator you will find there is a low pressure, because centrifugal force means, now let me just explain you with the diagram. So here this is the inward movement, and what happened? This is atmospheric pressure. Is here you can find the even height here of the atmospheric layer. So this is atmosphere. This is Earth. So what happened here? The air actually, it is because of the centrifugal force, there is a which movement is taking place? It is going down, creating a more pressure. That's why there is on poles you can find there is a high pressure is found. Both the poles you can find there is a high pressure. But here there is a outward movement takes place. That's why Earth even is bulging, and even the atmosphere also you can find it is here the altitude is very high. So this outward movement, the air is thrown, and that's why on equator there is a low pressure is formed. So this is how actually the rotation of the earth also affect the atmospheric pressure. Now let's see about the next thing is the representation of pressure. Now usually the representation of pressure, atmospheric pressure is represented by an imaginary line. What we call? We call it isobar. Now let me show you what are the isobars on the board. So here you can find these are the lines and it is written here. So 997 millibar. Now this is a line which joins all the places having same atmospheric pressure, that is 997. Now here this line, this is 990. So here this line, it joins all the places having how much atmospheric pressure? 990. Now this is so now here this is the line which joins all the places having how much atmospheric pressure? 1000. So these are the imaginary lines drawn on the map which shows the atmospheric pressure. These lines are called isobars. So this is the representation. On these are the maps are called weather maps, and this is how the atmospheric pressures they are being represented on the map. Now let's move to the distribution of pressure on the earth surface, means the pressure bed. For this again I have to draw the diagram. On equator, there lies a permanent low pressure belt. We call it equatorial low pressure belt. This belt is a permanent pressure belt of a low pressure, and this is also known as the doldrum. So all of you just if it is not visible, if your net connection is slow and this diagram is not visible, you open your book also, and in the figure 13.4 you just look the figure also there in your book. It will become easier for you, and you can find this is a low pressure belt, permanent low pressure belt. We call it doldrum. Now next is the subtropical high pressure belt. This is short form, subtropical high pressure belt. Now these are also known as horse latitude. So I will explain you why they are called horse latitude. I will explain you afterwards. In the temperate region, there is again low pressure belt, permanent low pressure belt are called temperate low, both hemispheres. So in the short form here, so these are the temperate low pressure belt. And on the poles there is a polar high pressure belt, permanent high pressure belt. We call the polar high. So these are the permanent pressure belts on equator. It is the equatorial low pressure belt, we call it doldrum. In the tropical region, there is a subtropical high pressure belt, we also call it horse latitude, both the hemisphere. In the temperate region, there is the temperate low pressure belt, we call it temperate low in the both the hemisphere. And on the polar region, the permanent high pressure are called polar high. Now let us see here one by one. First of all, about the equatorial low pressure belt. This I explained you about that due to the centrifugal force, all of you know, the air is being thrown out here on the equator. And this is why there is a permanent low pressure belt is formed, and that's why we also call it doldrum. Now the word doldrum actually it is derived from the Latin word, and the meaning of doldrum is associated with gloomy, listless mood, sultry air or variable breeze. Now usually this type of condition we can experience in our place also in the month of August and September, when you can see temperature is very high, it is very hot, and humidity is very high. Because of the high humidity and high temperature, we feel very uncomfortable. Even temperature is not so high, temperature is about 32, 33, maybe 31, but we feel very uncomfortable, and we precipitate very high, right? And the sweat, it's very difficult to dry up. That's why most of us, we want the room where the AC is there. Why? Because AC, it just take out all the moisture from the air. But outside you will find we are very uncomfortable. Why? High humidity. So this type of atmospheric condition can be experienced here in the equatorial region. It is a very permanent type of climatic condition can be observed in this region, equatorial low pressure region belt. Next is the subtropical high pressure belt. On the tropical region, there is a high pressure belt. And these high pressure belts, why they are called high pressure belt? Let me explain you. They are called horse latitude. In old days, means in the medieval period, usually when there was a lot of migration was taking place between Europe and America, large number of people, they were migrating from Europe to North America and South America. But what happens? They need to go from this region. And usually these ships were very heavy loaded. And as at that time in the 18th century and the 19th century, there was no roads were developed in the continent of North America and South America. So these people, they used to take large number of horses with them. So when these ships, they move from this region, subtropical high pressure belt. Now because of the high pressure, as the air is very heavy, it exerts very heavy pressure on the ship, and already these ships were overloaded. So they start sinking, and to avoid this sink to be drowned, so first of all what they do, they throw the horses in the ocean. So this was done many times, and this is why this subtropical high pressure belt, this whole region is named after, this is also called horse latitude. So I think all of you understood. Now next is in the tropical temperate region, there is a permanent low pressure is belt and the both hemisphere, and we call it temperate low pressure belt. Then we have seen the polar high, and I explained you what happened, because here because of the centrifugal force, the wind is, there is which pressure is taking place? Inward movement. The pressure, the air is creating more pressure, and that's why you can find there is a permanent high pressure belt is formed there on both the poles. So this is about the description of this distribution of the pressure belts. Now in the next video we will start about from the wind system of the earth. So all of you just read this chapter. Your homework is to read the chapter 13, because if you will read this, then it will become easier for you, right? So today, all the best.